Hey guys, my name is Gabe Graves and today we'll be going over Physics Lab 4. So the main purpose of this lab was to observe a mass oscillating vertically on a spring while swinging in an arc, and then to compare the experimental results from that to a computational model that we make in GlowScript. Additionally, we use the period of oscillation, kinetic energy, gravitational potential energy, and spring potential energy to determine the spring constant and the total energy of the system. Some key equations that were used would be the gravitational force, Newton's second law, the spring force, F net being Fs plus Fg, where Fg is always in the negative direction, whereas Fs can be either positive or negative, and the change in total energy being negative, or just the change in the gravitational potential energy plus the change in the spring potential energy plus the change in kinetic energy. And two of the main key concepts used would be Newton's second law and the change in total energy. So here's a video of my tracker data that I used. As you can see here, I basically treated the mass as a point object and mapped it out as the x swung in the left and right, whereas the y oscillated up and down. And that is how I got my experimental data. And so here are the key data points. I got 6.87 for my spring constant, and I got that from the equation here on the right. I got 1.52 for my period of oscillation, and that was the average in the y direction. And then for my O naught, I got 0.127, and that was also used from this equation on the right. And then the rest is just basically what was used mainly in the GlowScript code. So we already know that the mass was 0.402 kilograms, and the rest are just the key equations that I used in my GlowScript code. So here's the GlowScript code used for initial conditions. As you can see, my initial starting vector for the position was negative 0.124 in the x, negative 0.641 in the y, and 0 in the z, and then 0 throughout for the initial starting velocity. For the rest of these, you can basically just see that I use 9.8 for the gravitational acceleration, and then these two I discussed. And then this is basically what was used to describe the L vector as well as the change in the spring's position. And then this was used for updating the energy. So this was the starting values for the energy graph. So here's the GlowScript code used for my while loop. As you can see, just the gravitational force was only in the y, and that was negative. And then also my spring force was only in the L hat, and that was also negative. And F net was F spring plus F gravitational. And then also it should be noted that, of course, the velocity and position of the ball were updated, as well as updating the spring values and the energy values for the two graphs respectively. So here's a video of my computational model for the change in energy. The kinetic energy was blue, gravitational was green, spring was red, and total change in energy was orange. And it should be noted that the change in energy over time stayed 0. So here's a video of my computational model for position. As you can see, the experimental model was red and the computational model was blue. And the experimental model seemed to have a little bit of a less amplitude and period of oscillation, and this can perhaps be described to not being a perfect system and there being friction involved, which is thus bleeding off the energy of the system. So what does it mean? For part one, in terms of the conservation of energy, especially for the computational model, is the energy principle satisfied? Yes, it is. And this can, and the reason for this is that the change in total energy is 0. And this can be explained through the potential energy. When it's positive for gravitational, it is negative for the spring, and vice versa. And this can also be inherently shown through just the two equations for each one. So for the gravitational, it's negative, and for the spring, it is positive, and so they are inversely related to each other. And then also the overall, just the change of the potential kinetic and uh, potential of the spring, or so is potential of gravity and the spring. Those all added together would be 0 for the change in each of them. So what does it mean in terms of oscillation periods? For the average x position, I got 1.67 seconds, and for the average y, I got 1.52 seconds. This can perhaps be described how the spring constant was in each direction. So perhaps it was a little bit less in the x direction, which is why I got a higher period of oscillation, a little bit more in the y, which is describes it lower. And it should also be noted that the x graph is a sine graph, whereas the y is a cosine graph. So some possible sources of error. First one could have been human or plotting the tracker data, and the second one could have been the period points that I chose to calculate the spring constant. And that is it. Thank you.